All right, this is Perry University. Today we're going to go over 2's complement binary. So in 2's complement binary, this is binary but with negatives. And 2's complement is actually the most common way to write binary, both as a positive and a negative, and we're going to find out why it's super important. So this is going to be identical to unsigned binary numbers, except one big difference. So in 2's complement, your most significant bit, which is going to be the bit all the way on the left, is going to be your biggest powered bit, it's going to determine the sign. Of course, by sign, I mean positive or I mean negative number. And positive is going to be 0, and negative, of course, is going to be 1. All right, let's go over how we're actually going to take the 2's complement of a number, particularly a decimal number, and convert it into a signed binary number. For this walkthrough, we're just going to assume it's 4 bits, and we're going to work with the number -5. Okay, so step 1, we need to find the binary value of the absolute value of the given decimal number. That's easy enough. -5 equals 5, and then 5 in binary is just a 4 and a 1. So we have a 1, no 2, but we have a 4. We don't have 8. So that's going to be our binary value for just 5. Step number 2, we're going to invert all the bits. All your zeros become 1s and all your 1s become 0. So 0, 1, 0, 1 goes to 1, 0, 1, 0. All right, easy enough. Step number 3, all you do now is just add 1. So we'll take our 1, 0, 1, 0, and we're going to add 1 to it. And what I like to do, I'm going to fill in the zeros just to match the number of bits. So we have 4 bits on top, 4 bits on bottom. So 1 plus 0, that's just 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is, again, 1. And now you're done. 1, 0, 1, 1 in binary for 2's complement signed equals -5. All right, real important note. Your professor, if you're taking tests on this, is going to have to tell you that this is a signed value in 2's complement. If you don't know that, then what you think you're looking at is, let's see, 1 plus 2 plus 8. That looks like 11. So be very mindful of that your professor is going to have to specifically say, this problem is a 2's complement problem. That's just a little test taking tip. All right, now let's go in the other order. Let's go from 2's complement signed binary and put it in decimal form. Step number 1, invert all the bits. But big important thing here, make sure you write down whatever the sign is from your binary number. Let's go ahead and change our -5 to 1011, sign 2's complement, which we know is going to be -5 in decimal, since it's what we just did. Now we can kind of see the reverse order here. All right, so we have 1011. Remember your leading bit, or your MSB, right here. That determines the sign. 0 is positive, 1 is negative. We have a 1, so we need to make sure that we know we're going to end up with a negative value. On top of that, we need to get all of our bits converted. So that becomes 0, 1, 0, 0. All right, good start. All right, once again, we're going to go ahead and add 1. I'm just going to use what we already have written here. So I'm just going to do plus 1. I'm going to fill in my zeros. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 0 plus 0 is 0. There we go. Now all we have to do is convert it to decimal like normal, and don't forget the sign. So we already know that 0, 1, 0, 1, that's 1, that's 4, so it's going to be 5. But please remember your sign. And there you go. You're all done. That's how you convert a number to and from decimal and binary using 2's complement. All right, let's go back to discussing range. So what's going to be your most positive number? Let's remember, if we're going to use 4 bits, let's just use x's to fill in for zeros and ones. Your MSB, or your leading bit, is going to be your sign bit. That means there's 3 bits left to actually determine the magnitude of your number. So when you think about how large the number can possibly be, normally it would be your base to the power of n minus 1, but now we lost one of our n values. So it's 2 to the n minus 1 minus 1. So for 4 bits, what's the largest possible number it could be? Well, let's assume it's positive. And that would mean your other 3 bits are turned on. We already know that 1, 1, and 1 is 7, but let's just write it out longhand. We're going to end up with 2 to the 4 because there's 4 bits, but 1 is given to the sign bit, and then we have to subtract 1 because we start at 0. That equals 2 cubed minus 1, which of course is 8 minus 1, which is 7. So a 4-bit 2's complement number cannot be any larger than 7. Now what's your most negative number? So you would think that your most negative number would be just -7, but that's not the case because 0 is counted as a positive number. So when you're determining your most positive number, 2 to the n minus 1 minus 1, this minus 1 is there to account the fact that we start counting at 0, but we don't count 0 when going in the negative direction. So you're left with just 2 to the n minus 1. So in this case, that would be 2 to the 4 minus 1, which equals 2 cubed, which equals 8. Of course, we're going negative, so let's tack on all of our negative signs. Now, what does that look like in binary? This is actually going to be a 1, and all your other bits are going to be 0. And that's going to be true regardless of the bit count. Even if it's a byte, which is 8 bits, your sign is going to be 1, and then the other 7, if we're using a byte, there'd be 7 other bits left over, will all be zeros. So we're back to 4-bit, and we have 1, 0, 0, 0, and we've been told it's 2's complement, so we know our leading bit is negative. So let's invert all of our bits. 0, 1, 1, 1. Now we need to add 1. 1 plus 1 is 2. 1, 0. 0 plus 1 plus 1, again, that's 2. 1, 0. We end up with 2 again. Now we end up with 1. 1, 0, 0, 0 unsigned, we already know is 8. But we have to remember our sign, which comes from here. We know it's negative. So we actually have -8. And from here we can see that anytime you have a 1 with leading zeros all the way down, that's going to be your most negative number based on the bits you have. So the final piece of information I'll leave you with is the total range, which is going to be from your most negative, which is going to be -2 to the n minus 1, all the way up to and that's going to be your range for any 2's complement number with n bits. I hope you learned something. I hope this is helpful. I hope you use this to help ace any tests you have coming up. Thank you for stopping by and listening to this. I hope you guys have a great day.